A very good morning to all. My name is Sapna and I am working as an assistant professor in CSC department made Maharaja Agrasen University, Baddi. And my today's topic is projections, which comes under computer graphics. So let's learn what projections are. First of all, let's see what will be the contents we will cover in this tutorial. Number one, what projection is. Then its types, that is perspective and parallel projection. And we will also learn the further types of perspective projection, that is 1 point, 2 point, and 3 point projections, perspective anomalies, and also the types of parallel projections, that is orthographic and oblique projections. Okay, now let's continue to what projection is. So basically, projection is a process of converting a 3D object into a 2D object. We all have seen a sketch like this one, like an apple on a book. This sketch is drawn on a 2D paper, which is obviously two-dimensional, but it is visible as 3D object. So it is done by creating some angles, or um, it appears to be in 3D. So basically what we are doing is, it is defined as mapping or transformation of the object in projection plane or view plane. Now what this projection plane is, what is a view plane? View plane is basically the displayed surface, the surface on which we can see the object. In other words, we can say a projection is a transformation from an n-dimensional space to an m-dimensional space where m is less than n. It means if I'm taking a 3D object and transforming it into a 2D object, then it will be called as projection. Okay, I hope you get the basic idea what projection is. Let's come to its classification. So the projection is basically divided into two parts, that is parallel projection and perspective projection. Parallel projection is further divided into orthographic and oblique projection. So an orthographic is further divided into multi-view and axonometric, which is further divided into isometric, diametric, and trimetric, whereas oblique is classified into two, that is cavalier and cabinar. And in parallel to that, perspective is divided into 1 point, 2 point, and 3 point perspective projection. So this chart shows the classification and the types of projection which we will study in this class. Let's move to the next topic, that is, okay, so before studying perspective projection, we will come across a few terms, few important terms that are related to it, and it will help us to have a deep understanding of the topic. So first of all, what is a view plane? View plane is an area of world coordinate system which is projected into viewing plane. In simple words, we can say the displayed area, or the area where we can see the object or the image, is the view plane. Next is center of projection. It is the location of the eye on which projected light rays converge. As we all know, we can see objects when the object reflects light and it enters our eyes and we can see that object. So While all this process, the location of the eye on which those light rays converge is called center of projection. Then what projectors are? Projector is basically the projection vector. Those rays that are converging, those rays are projectors. Um, it is much similar to the projector we use as an output device. These are the rays start from the object seen and are used to create an image of the object on viewing or view plane. Okay, let's come to perspective projection. Now, perspective projection is farther away object from the viewer, small it appears. What does this mean? If the distance between the object and the center of projection is increased, the object will appear to be smaller. This property of projection gives an idea about the depth. That means how far the object is. Okay, now the perspective projection has two main characteristics that are vanishing point and perspective foreshortening. Now, due to this foreshortening, object's length appears smaller from the center of projection. More we increase the distance from the center of projection, smaller will be the object. We will further see this. Application of perspective projection are generalization of principles used by the artist in preparing drawings of 3D objects and scenes. It is as similar as the previous picture that we have seen, that apple on a book which is drawn on a 2D paper but appears to be in a realistic 3D world. Okay, so we have two types of perspective anomalies that we have recently studied. Perspective foreshortening. The size of the object will be small if its distance from the center of projection increases. As you can see in this picture, that the farther the tree is, the smaller it appears. So the trees that are further appear to be smaller. This property, this anomaly is called perspective foreshortening. And you can see in the second picture that all the railway lines appear to meet at a point. But is it possible in reality? No, it's not, because the railway lines are parallel. And if they are parallel and they appear to meet at that point in a picture, then we will call that point vanishing point. So what vanishing point is, all lines appear to meet at some point in the view plane. Then we will call this anomaly vanishing point. I hope you get what perspective projection is. Now, perspective projection is based on number of vanishing points, and on the basis of vanishing points, we will classify perspective projection into three types. One is one point projection. You can see when the projection is from the one point, we will call it one point projection. For two, in the second picture, we can see for two directions, it is 2-point perspective, and for three, it is 3-point perspective. I hope you get the basic idea about what is perspective projection. Then we have parallel projection. Now, what parallel projection is? Parallel projection discards the z coordinate. Z coordinate due to which the 2D and the 3D objects appear to be in 3D. So we will discard that Z coordinate, and parallel lines from each vertex of the object are extended till they intersect the view plane. In parallel, we specify a direction of projection instead of center of projection. As you can see in this diagram, that center of projection is at infinity, and we can only see the direction of projection but not the center of projection, because all the rays that those projectors are parallel to each other. So in parallel projection, the distance from the center of projection to the project plane is infinite. In this, we connect the projected vertices by line segments which correspond to connections on the original object. These projections are less realistic, but they are good for exact measurements. In this type of projection, parallel lines remain parallel and angles are not preserved. That means angles could be changed. Okay, now parallel projection is further divided into two types, that is orthographic and oblique. So what orthographic projection is? Orthographic projection is used to display picture in its true shape and size when the projectors are perpendicular to the view plane. Perpendicular means when the projector is at 90 degree to the view plane, then this is called orthographic projection. The architects and engineers use this type of projection for creating working drawing of the object. Orthographic projection is further of two types, that is multi-view and axonometric orthographic projection. In multi-view orthographic projection, you can see that if we see this object from the top, there are three directions A, B, C, and if we see this object from the top, so parallel projection from the top would be the B part, would be represented as the B part, and from the direction B, we can see the parallel projection as C part, and from the parallel projection from top, that is in C direction, it can be seen in the D part. So these are the three multi-viewing orthographic projections. Next, we have axonometric orthographic projection. So all projection plane to move relative to object. When the projection planes move according to the or relative to the object, that means the angles and the direction to which the object rotates, the projection plane will move according to that. That means projection plane is relative to the object. So axonometric orthographic projection is further of three types. One is isometric projection. In isometric projection, all the projectors make equal angle. Generally, angle is of 30 degree. As you can see in the isometric projection, the third figure, we can see the object is making 30-degree angle with the center of projection, and in diametric we can say two projectors have equal angles. It could be seen in the first figure. Then we have trimetric. The direction of projection makes unequal angle with their principal axis. As we can see in trimetric, it has unequal angles with the principal axis. Next, we have oblique projection. In oblique projection, there is an arbitrary relationship between projector and projection plane. Arbitrary relationship between projector and projection plane. So, which could be easily understood by the two types of oblique projection. That is, one is cavalier, other is cabinet. So, in cavalier, what is this cavalier? All lines perpendicular to the projection plane are projected with no change in length. The object will be as it is as its length. All line that will be perpendicular, that means in 90 degree to the projection plane, are projected with no changes in length. As you can see, if I take A, B, C are the vertices, are the sides of this cube. If I take it to be a cube with 1 unit of length, so we can see that it is at equal distance and perpendicular to the projection plane, and there is no change in its length. But while we can see cabinet, in cabinet we can see that the length of C side is half of the other side. So the C side is half of the length. That means it appears to be, it looks like a cabinet, that's why the name. All lines perpendicular to the projection plane are projected to 1/2 of their length. These gives a realistic appearance of the object. As we can see, the second one, the cabinet projection, appears to be more realistic, right? I hope you get the oblique projections. Thank you so much. That is it for the lecture. Thank you.